All right, so we left off thinking about this lovely concept as it relates to your life, that where you end up is wherever you start, plus a collection from that start time to that end time of all of your changes with respect to time. All right, I'm going to take you through some practice problems. I'm going to have you pause the video a lot to try things and then look back at my work and check and listen for explanations, okay? So example 1 out of n, where n is an element of the positive integers. So we don't know how many we have, but we are somewhere in the positive integers. Let me change to my fancy pen. So I am integrating from t equals -1 to t equals 2, 7 minus 3t dt. So I'm finding the area under the curve between -1 and 2 of this line 7 minus 3t. Well, I learned in the video from before about the fundamental theorem that there's a nice shortcut that I can take. And that is, this sign says take the antiderivative. So taking the antiderivative using my power rule, I'm going to have 7t minus 3t squared over 2, because you increase the power by 1 and divide by 2. And this time I don't need a plus c. I need to evaluate that antiderivative from -1 until 2. You can put in those t's just so we remember that those were t values if you would like to. So thinking about this, I'm going to evaluate the top number first. So 7 times 2 minus 3 times 2 squared over 2 minus, that's f of b, minus f of a, which is going to be 7 times -1 minus 3 times -1 squared over 2. And I can go through and do this all by hand, or I can type stuff into my calculator. You could go step by step, but we should expect that we should be able to evaluate this, and we end up with 21 minus 9/2. So 21 minus 9/2 is going to be 42, minus 9 is 33/2 would be your final answer. Okay? Next one, I'm going to strongly suggest that you multiply out first. So we don't have a product rule, so instead we actually have to do the multiplication. X squared minus 4x plus 16. When I say minus 4x, I definitely mean minus 8x. My apologies. Been making a lot of videos recently. X equals 1, x equals 4. So go ahead and pause your video, see if you can get the antiderivative evaluated, f of b minus f of a. Pause now. Okay, so I took the antiderivative of each piece individually, plugged in 4 for each of my x's, minus, keep those parentheses around there, plugging in 1 for each of my x's for a total answer of 9. Next one, example 3. I would strongly suggest that you write this one as 1 to 8 of the square root of 2 times x to the -1/2 dx. You can take the square root of 2 out in front and completely ignore it. Go ahead and try this one. See what you get. Pause your video. All right, I took the derivative. I plugged in 8. Sorry, took the antiderivative. Boy, I'm all over the place. Took the antiderivative, plugged in 8, then plugged in 1, subtracted, got 8 minus 2 root 2 if I was being very careful with my square roots. Or if I typed a bunch of stuff into my calculator, not rounding at all until the very end, 5.172. All right, the next one. Don't have a product rule for integrals, so I'm going to distribute this guy. So I'm going to have the integral from 0 to 2 of 6x to the 1/2 minus x to the 3/2, because this would have been a 1/2, this is a 1 whole, 1.5, etc. dx. And again, you can write these as equals to x. That's going to come into play a little bit later, so it doesn't hurt you to see it and start thinking about it, but that's up to you. Go ahead and see if you can complete this one. Pause your video. All right, this one, I got my exact answer when I plugged in 2, minus plugging in 0, but of course plugging in 0 to both of these negates everything, goes to 0. So just plugging in 2, you get 8 root 2 minus 8/5 root 2, or rounding in your calculator till the very end, 9.051. If you want to see more about this work, the answer key is scanned in online. You can see a little bit more of what I showed my work, but a lot of it is just how you clean up your algebra, okay? And that's going to be up to you as an individual student for how much you remember from your AAA, AATH, pre-calc days. Example 5. I'll help you get started with some rewrite. We don't have a division rule for integrals. So I'm going from -8 to -1. I'm going to write this as x over x to the 2/3 minus x squared over x to the 2/3. I'm going to clean up even more. So I'm going to go from -8 to -1. This would have been 3/3. So 3/3 minus 2/3 is 1/3. This would have been 6/3, because that's 2. 6/3 minus 2/3 is x to the 4/3. See if that helps you get started. To take the antiderivative, plug in -1, plug in -8, find the difference between them, and get that exact area under the curve. Go ahead and pause your video. Try for yourself. All right, so my exact answer came out as -1,839 divided by 28, or typing it all in your calculator, -65.679 for the area trapped under that curve. Just a reminder, okay, for how I'm getting these, I'm adding 1 to the exponent and dividing by that new exponent. Also, if you want to look at my work for how I get to these exact values, remember this 3 would say take the cubed root, raise it to the 4th power. Take the cubed root, raise it to the 7th power. Okay, so don't forget all those algebra things, otherwise you're just going to make your calculus life harder. All right, so let's see, what are we on? Oh, example 6 out of n. When will these n's ever end? So this one I can think about just as 2 separate pieces because we're just separated by subtraction. So the integral of 2 is just 2x. The integral of negative cosecant squared is going to be negative cotangent, but I actually want that to be positive because I want the negative to show up. And I'm going to evaluate from pi over 4 to pi over 2. I'm going to let you evaluate this one, see if you remember some unit circle things. Come back when you're done. Go ahead and pause. Okay, so unit circle stuff, cotangent of pi over 2 is 0, cotangent of pi over 4 is 1, but then I distributed that negative in. I ended up with pi halves minus 1. So close. Final examples. Good luck. So what I want you to think about is you actually have done these examples without knowing the antiderivatives. And with absolute value, taking antiderivatives is a pain because you have to break that function up into its positive slope and its negative slope and where does it break and what happens and blah, blah, blah. When you see absolute value, oftentimes you want to think, how can geometry help me? When you see the square root of a radius squared minus x squared, you want to think, how can geometry help me? So let's go ahead and sketch this graph. This is the absolute value v that's been shifted to the right 3. It's been flipped upside down, and it's been moved up 3. That was supposed to go to the origin. Let's try that again. And to here. All right, and I'm supposed to find the area between 1 and 4. So here's x equals 1, 2, 3, 4. Here's x equals 4. There's a lot of different ways you could break this area up. I'm going to choose to see it as 2 trapezoids. So this has a height of, let's see, 1/2 base 1 plus base 2. And then this is going to be a distance of 2. So that's that red trapezoid. And then I've got this blue trapezoid over here. This will be a 1/2. This has a base of 3 plus a base of, when I plug in 4 to this function, I get 4 minus 3, which is 1, 3 minus 1, which is 2. And then my height here is just 1. So this is going to be half of 4, which is 2, times 2, which is 4, plus half of 5, aka 5 halves. So this will be 8 halves plus 5 halves for a total of 13 halves. Okay? Last one then. I have a I don't want that in red. I have a semicircle centered at 0, 0 with a radius of 1, but I only want the positive top half, right? So thinking about this, -1 to 1, this has a radius of 1. I want to go from 0 to 1. So I'm looking for a quarter circle, a quarter of pi r squared, which is really just pi over 4. Now, something that we haven't shown you yet, but I'm going to now. Well, I can't really show you because I don't have the software on my computer because I'm at home, not at school. But if you press Math 9, you should get something that says F int. What will show up is an integral with some boxes and a box and a D box. What you want to put in is your A value, your B value, your function, dx. That will give you your decimal approximation. Remember, your calculator isn't perfect, so it's going to do some weird rounding stuff. It's not going to be exact. You should only use it on the calculator active portions. If it is a non-calculator active, you can check your work with fint, but you should do the work by hand. Clean up your fractions, clean up everything you can, okay? Use your calculator for arithmetic, and then check your answer with Math 9. If you have the older version of the calculator, you're going to show up with fint. You're going to type in the function, f of x, comma, x, with respect to x, from A to B. Okay, and that'll be your key notation that you need. So, some general no-nos. There is no multiplication or division rule for integration techniques. You've got to actually do the algebra. Only take a variable out of the integrand, the integral part, if the variable of interest is the same as the variable of what? What the heck-a-roonies? Only take the variable out of the integrand if the variable of interest is not the same as the variable of the infinitesimal. So the k can come out because the k has nothing to do with x. In this case, the x has to stay because the x, anything that's function or varying with that variable of integration, needs to stay there. Okay? What else? Limit your calculator usage. If you think you're supposed to solve the problem without a calculator, don't use your calculator. Maybe you try to check with it, but fint is really something you should only be using on a calculator active portion. Right? General advice. Think about the integral being geometric first, okay? Absolute value, those square roots of something squared minus x squared, or a line, those can easily be drawn out and use geometry. Way easier, okay? But algebraically, remember you might have to do some manipulation, some actual algebra to get there. It may take more than one time to find the correct antiderivative, and that's okay. Apparently Mr. Lakin invested in Kleenex. Cool. Take the derivative of your antiderivative just to make sure you found the right one. Go very slowly through the f of b minus f of a process. Make sure you are using parentheses around that f of a to get that negative sign to distribute. All right, if you are still stuck, there are some older videos about the fundamental theorem of calculus on Ms. Schwartz's YouTube. I think they're probably linked in Schoology, but you could request those if you need them. Otherwise, keep practicing. Fundamental theorem of calculus says the integral from a to b of f prime of x dx is equal to f of b minus f of a. So a shortcut for finding the area under a curve is to use the antiderivative evaluated at the endpoints and find the difference between. Congrats! You learned the FTC. Part 1.